All right, today is 11.3. We are going to go over parabolas. So you already know parabolas are quadratic equations, but mostly the parabolas we've been looking at have been symmetric with the y-axis, so they open up or open down. We're going to look at how we write equations if they open to the right and left also. So this is the definition of a parabola. The important thing to remember is that the parabola with a focus P and directrix L is a set of all points of x such that the distance from x to P equals the distance from x to L. And what they're talking about is this distance and this distance. So basically, any point on the parabola is going to be the same distance to the directrix as it is from the focus. Which then brings us to the equations on your formula sheet. So if your parabola opens up or down, it's going to be written as y equals. If it's opening right or left, it's going to be an x equals equation. If you notice, the y equals has an x squared in it, and the x equals has a y squared in it. And for both of these, your axis is either the y-axis or the x-axis, and we call that the axis of symmetry. So one thing you're going to see in problems that you're asked to solve are the axis or axis of symmetry is what they're going to say. And they're going to say the axis or axis of symmetry is the line, in this case, x equals 0. And then similarly, if you have a parabola that's opening right or left, they're going to say your axis or axis of symmetry is y equals 0. So that might be an important note to make on your formula sheet. All right, so you looked at those equations and you're probably thinking, well, what is P? So P is just the distance from the focus to the directrix and the distance from the directrix to the vertex. So the focus to the vertex and the vertex to the directrix are going to have the same distance because it falls in that definition that any point on the graph, including your vertex, is going to be the same distance to the directrix as it is to the focus. And that's no matter which way it opens. All right, so here we need to show that the graph of the equation is a parabola. So we're going to draw the graph and then find and label the focus and directrix. So like we saw on the previous page, we need these to be equal as set as y equals or x equals. So this one you can see the y is squared and the x is not. So we're going to want to solve for x on this one. So if we subtract y squared from both sides, we get negative 12x equals negative y squared. So then we divide by negative 12, so we get x equals positive 1/12 y squared. So those fractions you're going to want to write as coefficients. Now what we need to do is to be able to find the focus and directrix, we're going to assume, and just based on how this is, it's centered at 0, 0. And since it's an x equals, the axis of symmetry is the horizontal axis, the x-axis. So our axis of symmetry is the equation y equals 0. And it's positive, so it's going to be opening to the right. So our focus is going to be to the right of the vertex is what that's saying. But first we need to find the value P so we can tell where our focus and directrix are. So if you notice, these equations are written as x equals 1 over 4p y squared. So this 12 is in place of this 4p. So we're going to say, okay, 4p equals 12. So then if you divide by 4, you get p equals 3. Since p is 3, that means your focus is going to be 3 to the right, since it opens to the right, 3 to the right of the vertex, and then the directrix will be 3 to the left of the vertex. So if our vertex is at 0, 0, we know it's opening to the right because it's x equals positive 1/12 y squared. So since it's opening that direction, focus is going to be to the right, 3. So your focus is at the point 3, 0. And then your directrix is going to be 3 to the left in the opposite direction. So then your directrix is the equation x equals negative 3. Now to draw in our parabola, we're going to want to use a specific point. So since we know that our graph is opening to the right, because it was positive 1 over 12y squared, we are going to just plug in any point x value that's to the right. So I'm going to plug in x equals 1 to my equation that I got here. So I got x equals 1/12 y squared. So 1 equals 1/12 y squared. So I'm going to multiply both sides by 12. So 12 equals y squared. So y equals plus or minus root 12. And square root of 12 is about halfway in between 3 and 4. So a little closer to 3. So the y value for that is going to be about, we'll say 3.5. So when x equals 1, we're doing about 1 plus or minus 3.5. So 1, 3.5, 1 down 3.5. So then your parabola is going to look something like this. And it said draw the graph, label its focus and directrix. All right, in this equation, we are given some specific points and we have to figure out what the focus, directrix, and equation are of this parabola. So basically, we need to find what P is given some certain points. So we're looking for the equation of the parabola that passes through the point square root of 20, -5. So if we graph that, square root of 20 should be somewhere in between 4 and 5. So 1, 2, 3, 4, 5. So somewhere in between there, and then -5. So your point would be somewhere down here for that. So that's going to be a point on the graph, so on the line of the parabola. And the vertex is at 0, 0. And the focus is on the y-axis. So the focus is somewhere here. So that means we know it has to be opening down based on where this square root of 20, -5 point is. Okay, so if your focus is on the y-axis, that means it's going to have to open down based on where this point square root of 20, -5 is. So since we know that, we know then that we're going to be dealing with a y equals -1 over 4p x squared. That's what it looks like if it's opening down. So we need to find the focus and the directrix, and we already kind of found the equation. In order to finalize that, we need to find P. So we have to think what pieces of information are we given that might help us solve this problem. Well, if you look at our xy point here, the square root of 20 represents x, and the -5 represents y. So we're going to put -5 in for y, and we're going to put square root of 20 in for x. So we get -5 equals -1 over 4p square root of 20 squared. Square root of 20 squared is 20, so we have -5 equals -1 over 4p, and actually we can write that as 20 over 4p. Excuse me, -20 over 4p. And then what we end up getting is, let's see, -20 over 4. I'm just going to simplify that. We get -5 over p. And then if we were to cross multiply, you'd end up with -5p equals -5. So p equals 1. So since p equals 1, our equation is y equals -1 over 4 times 1, which is 4, x squared. So that's our equation. Since p is 1, your focus is going to be 1 away from the vertex. Since we know our vertex is at 0, 0, and our parabola is opening down, our focus is going to be 1 below that. So your focus is going to be at 0, -1, and then your directrix is going to be 1 above your vertex. So our directrix is going to go through y equals 1. So it's going to be that horizontal line, y equals 1. So we have the equation, y equals -1/4 x squared, the focus, 0, -1, and the directrix, y equals 1. This would be a similar process if your parabola was opening to the right or the left or up, but just use the clues that you're given to figure out which direction it is, and it should be pretty algebraically straightforward from there. So that should give you, parabolas are pretty straightforward, so that should give you enough information to get started. Try that 11.3 worksheet to practice going through some of the problems. Once you're feeling comfortable with that, the graphing, the finding the pieces, and solving other problems with them, you can go ahead and try your daily task.